In this video, you will learn about cube roots. Now, cube roots are basically the opposite of cubing something. So we've learned in the past that to cube something means you're raising something to the third power. So for example, you might have 0 cubed means you have 0 times 0 times 0, which would be 0, right? So the cube means you're multiplying it 3 times together. So if you had 1 cubed, that'd be 3 1s multiplied together to get 1. 2 cubed is 3 2s multiplied together, that would give me 8. 3 cubed means 3 3s multiplied together, which would give me 27. 4 cubed would be 3 4s multiplied together, which would be 64, and etc. Now a cube root is the opposite of cubing something. So for example, I can ask for the cube root of 0. So the cube root of 0, you'd write it like this, with a little 3 up here and the 0 inside. What that means is it's asking what number to the third power gives me this 0 inside. So what number cubed gives me 0? That's going to be 0. Okay, now what about the cube root of 1? So that's asking what number cubed gives me 1. We see here, 1 cubed is 1, so my answer is 1. Okay, now what about the cube root of 8? So this means what number cubed gives me 8. So what number multiplied 3 times gives me 8? Well, that's going to be the number 2. We see that right here. Okay, now what about the cube root of 27? So this is asking what number cubed gives me 27. So we see here is 3, because 3 cubed, or 3 times 3 times 3, is 27. And I could keep going if I wanted to with the cube root of 64. Cube root should be 3. Cube root of 64. That's asking what number to the third power is 64. We see over here that that number would be 4. All right, because 4 cubed is 64. So notice that cube root is basically the opposite of cubing something. And so we could keep going and get cube roots of pretty much any number. Now let's continue this conversation and extend our study to include negative numbers. Now what if you had negative 1 to the third power? That means we have 3 negative 1s multiplied together, which when you do that would be a negative 1. What about negative 2 to the third power? Well, that's 3 negative 2s multiplied together, which would give me negative 8. Negative 3 to the third power is 3 negative 3s multiplied together, which would be negative 27. Negative 4 to the third power is 3 negative 4s multiplied together, which would give me negative 64. Okay, so the process is the same, but now we have a negative number as our answer after we cube. And with cube roots, we can also take the cube root of a negative number. So here if we take the cube root of negative 1, what this is asking is what number cubed is equal to negative 1. And we see here that's going to be the number negative 1. Now if you had the cube root of negative 8, that's asking what number cubed gives me negative 8. And we see right here we have negative 2. So the cube root of negative 8 is negative 2. We can keep going. Cube root of negative 27 is asking what number cubed is negative 27. Well, we see right here that number is negative 3. Now the cube root of 64, or negative 64, is asking what number cubed equals negative 64. We see right here that negative 4 cubed is negative 64, so negative 4 is my answer. So with square roots, like a square root of 1 or negative 1 for example, with the square root we have no solution or no real solution if you have the square root of a negative number. We would say this is not real or imaginary. Alright, that's true for any square root of a negative number. So the square root of negative 16 is imaginary as well because of the negative inside. Now notice that it's different than with a cube root. With a cube root of a negative number, we do have an actual number answer back out, because when you cube a negative number, you get a negative answer. Whereas if you square a negative number, you can never get a negative answer back out. Now let's pause for a moment and take a look at each part of a radical, because there are different terms that we have for these different parts. So we have this 4, we have this radical sign, then we have this 3 right here. So this 4 is called the radicand. Alright, so 4 is the radicand. The index is this number right up here. So this little 3, which shows that it's a cube root, that is called the index. And then this sign is called the radical sign. So make sure that you know these different terms, and especially the term radical sign and the term index. I would say that those are used more often than the term radicand, but still know the term radicand because you can see this word as well from time to time. So if you have a square root of something, let's say square root of 4, okay, normally we don't put this index up here, right? We just know this is a square root of 4, and that's going to equal 2. But if it's not written like this, we know it's a square root, which is the opposite of squaring something, right? So if you square something, that means your exponent is a 2. Alright, so with a square root, the index is a 2. It's an assumed 2. So if it's not written, the index is a 2. So here 2 would be your index, then we have your radical sign, then 4 still is your radicand. Now from here, let's work on simplifying cube roots. For example, if you have a cube root of 120, what you want to do is pretty much the same thing you would do with a square root. And with a square root, there are different ways you can simplify and pull numbers out of the radical. With cube roots, I'd recommend the one method, which is where you factor down the number inside. So if you factor down the radicand, the 120, factor that down as a product of prime numbers, we would get 40 times 3. 40 can break down as 20 times 2. 20 can break down as 4 times 5. And then 4 can break down as 2 times 2. So what I have is 120 equaling 2 times 2 times another 2 times 5 times 3. So we have 3 2's, a 3, and a 5. So I can rewrite this with all those factors inside the radical. So from here, now that I've factored, I can simplify by pulling out groups of numbers. Now with a square root, you are looking for groups of 2 things. With a cube root, you're looking for groups of 3 things. And we know that because of the index right here. That 3 means we're finding groups of 3 things. With the square root, remember, there's an assumed 2 here, right? So that's why we're pulling out groups of 2 things for a square root. But for a cube root, we're trying to find groups of 3 items. Here we see 3 2's. So these 3 2's make up one group. So I have one group, so I pull out 1, 2. And then those are now gone on the inside. So I now have a 2 on the outside, a cube root of, and then 3 times 5, which is 15 on the inside. So my simplified form of the original radical is going to be 2 times the cube root of 15. Let's take a look at another example. Here we have a 4 on the outside already. So 4 times the cube root of 144. Now again, to simplify, I would use the method where I factor down the number 144. Well, 144 is 12 squared, or 12 times 12. 12 can break down as 4 times 3. Do that for both of them. 4 can break down as 2 times 2. Do that for both of them as well. So 144, I can think of that as a 2, 2, 3, 2, 2, 3, all multiplied together. So I have 4 2's and 2 3's, which I can put inside of the radical. So 4 2's and 2 3's. Now to simplify, again, because this is a cube root, I'm trying to find groups of 3 things. Here we see a group of 3 2's. So I could pull out 1 2 because I have one group. So these are now gone. On the outside, I have 2 times 4, which is 8. And then we have the cube root of, and then 2 times 3 times 3 gives me 18. And notice nothing else could have been pulled out because here is a group of 2 3's, but I need 3 3's to pull out anything. So this right here is as far as I can simplify. So this is my simplified form of the original expression.